Good morning, grade 10s. I just wanted to make a quick little video for lesson 2. It's going to be really quick because the examples are only one page and I've already written everything in. So I'm just going to kind of talk over everything here and just kind of explain to you some stuff about parallel and perpendicular lines. So it says here that below we have a graph consisting of two parallel lines. Okay, parallel lines meaning they never ever touch. And another graph consisting of two perpendicular lines. And two perpendicular lines means they form an angle of 90, meaning they cross perfectly like that, like a shape of a T or a plus sign. And where they meet, that's a 90-degree angle. We're going to find the slopes of each of these and kind of find some relationships between slopes of parallel lines and perpendicular lines. Okay, so here, for this parallel line right here, I found the slope by going up 3 and over 4 to travel from this point to this point. So I got a rise of 3, run of 4. There's my slope, rise over run, 3 over 4. I did the same thing for the parallel line underneath. And lo and behold, to get from this point to that point, I also have to go up 3 over 4. So the slope is 3 over 4. So that makes sense that the slopes of parallel lines are equal. It's like they have the same slant. Okay, if they have the same slant, or if we were on treadmills, they'd be identical inclines. Okay, so the slopes of parallel lines are equal. Perpendicular lines, however, I'm going to zoom in here. For perpendicular lines, so for this one right here, I started with this point traveling to that point. I had to go up 5 and over 8. Okay, so that's how I got my slope of 5 over 8, rise over run. For the other line, to get from that point to that point, I had to go down 8 over 5. So because I went down 8, be careful, that's a negative there. And so if I put those together in a fraction for my rise of -8 over my run of 5, and we compared these two slopes, you'll notice that all we did for perpendicular slopes is we flip the fraction. So 5 over 8 becomes 8 over 5. And we give it the opposite symbol. So if it was positive here, we would be negative here. Okay, so it's the slopes of perpendicular lines are opposite symbol, and you flip the fraction. A fancy way of saying it is that they're opposite reciprocals. Okay, reciprocal means a flipped fraction. Opposite means the opposite symbol. So like I said here, this means you flip the fraction and put the opposite symbol in. Okay, so for this example here, it says that line GH passes through that point and that point. So imagine we had a line on a graph just like this, and I give you 2 points that the line passes through. I do another one. I say line JK passes through those 2 points. And finally, a third line, MN, passes through those 2 points. I want to determine if any of these lines are parallel to each other. So in order to determine if they're parallel, I had to find their slopes. So to find the slope of the first line, GH, I'm just going to use the slope formula. And you saw that in last lesson, y2 minus y1 over x2 minus x1. So if I'm finding the slope of GH, I use the 2 points given for GH. They were just given right there. And I use the formula. Okay, so y2 is the y value from the second point, so -1, minus y1. So that's the y value from the first point, -2. And then I do the same thing with x. So x2 is 2 minus x1 is -4. So be careful, you have the minus from the formula and the -4. That becomes -3 over 6, which reduces to -1/2. Then I do the same thing with the JK slope. So I use the 2 points given for the JK line. I do the exact same thing, plug them into the formula. -4 over 8 is what I get, and that reduces to -1 over 2. So right away, I can see that these two slopes are absolutely identical. Identical slopes means they are parallel. Then I just check with the third one, MN. I do the same process again with the 2 points for MN. When I solve this one, I get -4 over 9. So that is not equal to those, so it's not parallel. So that's why I concluded here that GH and JK are parallel. MN is not parallel to any of them. And last question, line PQ passes through those 2 points and line RS passes through those 2 points. So I'm just giving you 2 lines here, and I want to know, are they parallel, perpendicular, or neither. So in order to determine if they're parallel or perpendicular, or maybe neither, we have to find the slopes of both of them and compare them. So when I found the slope of PQ, again, I use this awesome formula here. For PQ, those were the 2 points I was given. So I plug in these 2 points using this formula, and I get 8/5. Then I do the same thing with the other line, RS. I use the formula. So for example, if it's y2 minus y1, y2 would be the 1, and y1 would be the -4. And that's what I threw in there. And I did the same thing with the x's, and I get 5/8. Now look at this carefully. Yes, these are flipped fractions. That is 8/5 and that is 5/8. But in order for two lines to be perpendicular, they have to have opposite symbols too. So these are both positive. So they're not perpendicular and they're not the same, so they're not parallel either. And then I just wrote here, sketch the lines to verify. So when I sketch these two lines, I just use the points here given. I drew the points and I connected them. We can see here that they're not perpendicular because perpendicular lines have to cross like this and make a plus sign. And they're not parallel either because we can tell that eventually these two lines would get closer and closer together and touch. So they're not parallel either. Okay, so there's just a quick overview for lesson 2. You'll see the optional assignment on the website, and stay tuned for more.